That's cute. It's my cord.
All right. So people following kind of where we're at up to this point, okay? We've gone through and we've created our centered variables. We've created interaction terms. We've gone through and we've built our multiplicative model. We've got our interactions. We've gone through and then factored that model, that regression equation out to get our simple slopes. We've plotted those out. But what we now want to do is go through and test those simple slopes. We want to attach p-values to the simple slopes that we've gone through and derived, okay? We can do that. It just takes a little bit more legwork in SPSS. Okay. So what I'm going to do here is I am going to go through and create new variables that correspond to high and low levels of pain. Okay, because I'm going to start out looking at the conditional effect of PTSD on outcome at high and low levels of pain. Okay. So what I'm going to do here is I'm going to take, I'm going to go through to look at my descriptives first, okay? And I'm going to go through and I'm looking at my descriptives for centered pain, centered opiate use, and centered PTSD, and this is what I'm getting right here, right? And so what I should see here is that my means are all sort of zero or approximately zero. We had a small rounding error here, but that's fine, right? But my standard deviations are going to be the same, right? But what I need to do now is I need to go through and create two variables, one where my pain variable is rescaled so that zero corresponds to a low level of pain, and another variable where zero corresponds to a high level of pain, okay? And so what I've got here is I'm going to compute my low pain variable, which is going to be my centered pain variable. And remember, if I'm creating low, I'm adding, right? So I'm going to add a standard deviation. My standard deviation pain 1.34187. So I've got C pain plus 1.34187. Run that, and I'm going to compute high pain. This is going to be my center pain variable minus a standard deviation. Okay. And what this is going to give me is it's going to be giving two new pain variables. In my center pain variable, zero represents what? The mean. When I go through and I set that low pain variable, where does zero set?
Standard deviation below.
Standard deviation below. And high pain, where does zero set?
Standard deviation above.
Standard deviation above. And so I'm going to use these to now rerun a model where 0 points start to correspond to different levels of pain. Okay. And so after I go through and I do that, if I go back through and I take a look at my model, what interactions do I have that involve pain? Well, I've got an interaction of PTSD and pain, and then I have an interaction of opiate use and pain. Am I interested in opiate use and pain at this point in the process? No, but I still got to go through and create those interaction terms so that my model makes some sense. So what I'm going to do now is I'm going to compute a new variable that's low pain by PTSD interaction. And then I'm going to compute another that's high pain by PTSD and then the interaction of that. And I'm going to have another one that's low pain by opiate use in that interaction, and then high pain by opiate use in that interaction, okay? What I would strongly recommend is as you're doing this, will have already written out your regression model. You go through and do the factoring, go back through and take a look at that and back, what are the ones that I need to substitute my pain in, making sure you're creating those interactions, okay? So what I'm going to do here is I'm going to go through, and I've got this already kind of queued up here. Here's my high and low pain variables, okay? I'm going to go through and I'm going to run these. And if I take a look at my model now, or my data set, now I've got a column for low pain, and I've got a column for high pain, okay? And if I go through and I take a look at my original centered pain variable, here's 1.26. My low pain should be that plus a standard deviation. My high pain should be this minus a standard deviation, right? We're just shifting around where zero is on this scale, okay? And then what I'm going to do is I'm gonna go through and I'm gonna say, okay, I have two interactions that involve pain in this model. I'm gonna create new interaction terms. One corresponding to low levels of pain, one corresponding to high levels of pain, okay? So I go through and I run these. And I can see now in my model, I've got interactions that correspond to low pain and PTSD, low pain and opiate use, high pain and PTSD, high pain and opiate use. All of this. And then what I'm going to do, I'm going to go to analyze, go to regression, linear, okay? And I'm going to get rid of all of my original model and repurpose this with sort of my new pain variables, okay? So I've got opiate use is my first variable, right? And then if I go back up to take a look at, or excuse me, I look at my original model here, right? I've got opiate use, pain, PTSD, PTSD by pain, opiate use by pain. I'm going to go through, I've got opiate use, non-centered pain. I'm going to go low pain, PTSD, and then PTSD by pain, but now it's going to be PTSD by low pain. And opiate use by pain, but now it's going to be low opiate use, or low pain by opiate use. And now I've just recreated my model, but every place there's a pain term, I've just replaced it with low pain. And if I go through and run this, this is what I'm going to get, okay? And then if I go through and I do the same thing and run the same model in SPSS and swap out high pain, right, which is what I've done here. So now I've got high pain, opiate use, PTSD, high pain times PTSD, high pain times opiate use, right? I've got my two simple slopes models, okay? And for this, so I've gone through and I've run this and I want to go through and I want to check to make sure, is everything working correctly? So if I'm looking at this, I'm seeing my intercepts are different. Does that make sense? Yep, intercepts should be different. My pain variable, that's the same. Does that make sense? Yep, because my moderator doesn't change with this. I've got different coefficients for opiate use. I got different coefficients for pain. My coefficients, my interaction coefficients, those are identical. Is this square with what we expect? Yep, I've got a properly specified model here. Things are looking good, okay? So after I go through and do all this stuff, I know what's the only thing I'm actually really interested in here?
In both models, like the center PTSD.
That's all I'm interested in, right? This is my conditional effect of PTSD on functioning at low levels of pain and at high levels of pain. And if I go through and I take a look at these coefficients, they should be exactly what I got when I actually factored these out by hand, right? We see that they are, right? And I have evidence now. I've got a p-value and I've got effect sizes associated with for my conditional effect of pain on functioning at low levels of pain. And then I got my conditional effect of PTSD and functioning at high levels of pain with corresponding effect sizes. I've got my tests of these models or of these specific effects. Does it make some sense to folks? Okay. And so if I go through now, when I'm going through and presenting this, and I want to talk about sort of this, I can go through and say, what I have is I have evidence of a negative association of PTSD on functioning controlling for opiate use at high levels or at low levels of pain. Then I can go through and put in p-value and sort of coefficient things along those lines. Effect sizes, same thing for this, right? So this is just adding a statistical test to what you've already created graphically. We're just going through and testing this out. Show of hands, don't be embarrassed. Did anybody read through Aiken and West? Daniel did. Okay. It's a pretty dry textbook. It'll make you appreciate Howland, Tabachik, and Vidal, but it's very, very good. And this is like the seminal text on sort of this process, right? So would strongly encourage you to go through and sort of read through that. I mean, it's like $100 for a tiny ass book. But Sounds like Danielle found a PDF
Yeah, you
at
can
some
find
point,
a
which is
PDF
awesome,
online,
so
but-
do that, right? But again, just to help you kind of solidify this process, okay? Questions about this? Okay. So now what about this? So we went through and we also went through and restructured our equation to look at the conditional effect of the relation, unique effect of pain on outcome for people who were and were not using opiates, right? So same thing here, right? And I've gone through and I got my simple slopes, and I've gone through and here plotted these out, right? Done all that stuff. Issue is though, what I still don't have is a test of p-values associated with these two slopes. I know what those slopes are. I calculated them right here. I just don't have p-values or effect sizes that I can attach to those, right? So we can go through and do the same thing. What's the only difference, or sort of what's the only sort of difference with this specific interaction relative to the last one? My conditional effect in this interaction. You see? Okay, yeah, you're right. What's my conditional effect here?
Opioids on pain.
Okay, so pain is going to be my conditional effect. Opiate use is my moderator.
Okay.
But you're exactly right. Opiate use is dichotomous, right? Do I do a standard deviation above or a standard deviation below opiate use? No, that doesn't make any sense. That's not a real value, right? What I can do is I can just set opiate use to 0 corresponding to no use. And I just recode it. So 0 means use. And then I just run it with 0 being opiate, 0 set to opiate use. 0 set to no opiate use, run the simple slope of pain. Reverse code that, so 0 now corresponds to use, run that, look at the simple slope of pain, and now I've got it all squared away, okay? So what we're gonna do here in your model is, do you need to create a new variable where opiate use is, where 0 is no use and 1 is use? Nope, we don't, because we already have that variable. It's just called opiate use, right? So that's already set up in our model, right? Or set up in our data set. But what we do need to do is we need to create a new variable, we'll call it opioid R, where we go through and swap this out. Now, there are different ways to go through and do this. In SPSS, it's probably just easiest to go through. If I go through and I say, for my opiate use variable, I go through and just sort that. Okay. And I go down through and say, all right, for this case, these are people with no opiate use. So I just plug in 1 and then just copy this in. Okay. And then for people here are people who are using opiates, but in my recoded variable, I'm just gonna paste in 0 for this. And then in my variable view, I'm just gonna go call this opioid R. And I just switch that around. Okay. So now if I go to analyze and I go to descriptive frequencies and I look at opiate use and opioid R, look at that. These should be the exact reverse of one another, right? Did I do this right? Yep. So I have in my opiate use 101 people who aren't using, 100 people who are. In my reverse coded, I got 100 people who are using as 0, 101 who aren't, right? Just make sure that you know what 0 means for both of these. Probably the better way to go through and do this is if you go to variable view for your new opioid R and just say value 0, is now use. And one. Labeling your variables is always the best policy, right? So now you know that this is just switched around. So you can go through. Okay. People see what we did there? Just flipping that variable around. Okay. Now what I'm going to go through and do is I need to go through though and create a couple of new variables here. What I need to do is I now need to create interaction terms with my uncentered opiate use variable and pain. Okay. So what I've got here, I'm going to create a new interaction that's no opiate by pain. Okay. How is this different than the one I had in my original model? Did we already do this before? We have with how did we enter opiate use in our base model?
It was centered.
It was centered, right? So I need a new interaction term, right? Where I have an interaction term that's sort of my original opiate use model where 0 is no, 1 is yes, times pain, and then a yes opiate by pain. This is now going to be opiate use R times pain. We're just creating new interaction terms here. Yeah, Lucy.
Just clarify with the opioid R, you reverse coded like opioid usage, but for our previous opioid variable, like that's just opioid, like it's coded the other way,
Yep,
right?
exactly. We're just flipping it around. Because again, what we're always concerned about is what does 0 mean? In my original opiate use variable, 0 means no use, right? But eventually what I'm going to want to do is I'm going to want to look at the conditional effect of pain on outcome for people who are using, right? But I need to create a variable where 0 represents people who are using. So I just go through and reverse that. Okay. So if I go through and I do that, and now what I'm going to do then, if in my model, I go through and I then compute my two new variables here. Go to the end. See my 2 new terms here. So now what I'm going to do is I'm going to go analyze, regression, linear. Okay. So now I'm just going to go down through, pull this out. So now for my first model, I'm going to have opiate use, centered pain, centered PTSD. Okay. And then I'm going to have my original pain by PTSD interaction, because that's just centered pain and PTSD, right? So drop that in. And now what I'm going to do is I'm going to have my no opiate use by pain interaction. So again, what I'm doing, I'm just recreating my model. But in my original model, I went through and I had my opiate variable was centered. Okay. For my simple slopes, what I want opiate use to be any place where there's opiate use, I want it to be sort of represented by my original variable where 0 is no use, 1 is use. Okay. So I'm going to go through and run this model. Hit OK. Then I'm going to go back up and I'm going to analyze regression linear. Same thing, sort of, but now I'm going to go through, get rid of all that. And I'm going to rebuild a model where I have, for opiate use, I'm going to use my reverse code, right? So here with my reverse code opiate, 0 represents use, 1 represents no use, okay? And then I'm going to go through, have centered pain, centered PTSD, okay? And then what I'm going to do is I'm going to say pain times PTSD because that interaction is fine, right? There's nothing involved in opiate use there. And now, yes, opiate use by pain. I'm gonna run that. And so when we do this, here's what we're gonna go through and see, okay? Here, I've got my centered pain where 0 corresponds to average pain use, okay? Opiate use here, 0 means no use, 1 means use. Here's my PTSD variable. Here's my pain times PTSD from my original thing. We didn't need to fool around with that. And now we have an interaction that's my original dichotomous opiate use variable where 0 is no use, 1 is use, multiplied by pain. Okay. And then when I go through and I'm going to flip this. Here's pain, here's opiate use R, and in opiate use R, what does 0 represent? People who are using, right? Here's my centered PTSD, here's PTSD by pain, that's fine. And then I've got an interaction where 0 corresponds to use of opiates multiplied by pain, okay? And again, if we go through, take a look, we see that our constant changes, that makes some sense, okay? Our pain coefficient changes, does that make sense? Yep, because that's our simple slopes. That was what we're actually interested in, right? Opiate use, does opiate use change? The sign changes on that, but the coefficient itself doesn't. That's just a function of reverse coding that. Okay, and here's something a little bit different. PTSD, does PTSD, my coefficient for PTSD change? No, it doesn't, right? Did it change last time? Yeah, it did. Did something go wrong in my model? Why does it make sense that PTSD didn't change in this version of my simple slopes?
The effect of PTSD isn't conditional on.
Yep, absolutely. There's nothing in my model that makes PTSD conditional on opiate use. And because of that, that coefficient didn't change at all, okay? And so that stays the same. Also, if I go through and I take a look at my interaction terms, those change? No, they shouldn't, right? Outside of there's a flipping sign just because we reverse coded that. But everything is looking really good, okay? Do people see what we did? And so this is actually, if I have a dichotomous moderator, this is actually a little bit slick because I don't have to go through and recenter high and low sort of values up above. And we take out some of the guesswork on how many standard deviations above and below. Well, I don't know. It's either this value or it's this value. Those are the only 2 values you can take, right? So it actually simplifies things a little bit with this. But do people see kind of the approach that we're going through and taking? And all we're doing is we're just changing what 0 means. And if we do that, we can start to make these models work for us and sort of ask some pretty interesting questions. All we're doing is just rescaling our variables to say, where does 0 go? Because the model is always going to tell you the unique effect of X on Y holding everything else constant at 0. That never changes. That's always the only thing that these models are ever going to do. What you can do, though, is start to become clever and start to change where that 0 is and what that means and start to tease out some interesting things. Okay. Now, one quick thing. Now, in our original model, right, I went through and I centered opiate use. Did I need to do that? Not really, but I like doing that because at the front end, before I test a model, I don't know what's going to come out, right? And so if I go through and I center those dichotomous variables on the front end, what it's doing is it's kind of holding those constant, right? So let's say that opiate use, so opiate use by PTSD interaction was 0.051, right? Let's say I'm a real hardliner back. Nope, it didn't cross, it didn't tip over. I'm not counting it as something I'm going to interpret. I don't have evidence for this, right? Really into dichotomous thinking, right? Well, if I went through and I had set opiate use at 0, technically that model is looking at the unique effect of all my variables when opiate use for people who aren't using opiates. But if it's kind of right there on the edge, even though that's not a significant effect, or I'm not interpreting that as a significant effect, my coefficients are still going to change around, right? So even if it's something that I don't care about, or if it's something that I don't find interpretable, I would rather be looking at the average level of this than at sort of one specific level, right? So what I will typically do is center everything on the front and then go back through and flip things around on the back end. Does make some sense? Okay. So, And again, if we go through and take a look at my simple slope of pain at both of these are going to be identical to what I calculated by hand. Okay. And for you, when you go through and you run your simple slopes for these write-ups, do you need to describe the whole goddamn model and tell me, nope, you sure don't. Please don't. The only thing we're interested in is that simple slope right there. That's the only reason you're going through and running all of this stuff. Yeah.
When we report that specific simple slope, would you also like us to like put down beta and T for that row or just?
Yeah. Give me, so, yeah, because again, what you're getting at is for people who are using or not using opiates, here's the effective pain and here's your effect sizes and stuff like that, right? So everything that you would report for pain that normally, so to still report those things, right?
Okay.
And then for people who are not using opiates, right? You're just going through and providing some statistical clarification for what's going on here. How are we feeling about this? Overwhelmed, show of hands. Ish. It's a lot to go through and say, here's what I would say, okay? When you're working through this, two things, and schedule out time to do this. One, at the end of this slide, there are links to sort of me walking through demos of another example of this, as well as a screening for this. Take time to just watch those, okay? Particularly if you're not feeling really confident in what's going on. It's just another example that you can walk through and sort of make sure that you're kind of catching on and process the patterns and things along those lines, okay? Screening for these isn't different, except for you're just including your interaction terms in your screening process, which you'll want to do, so make sure that you do that. So again, take some time, spend some time watching those. It'll probably save you hours and hours on the back end if you're feeling confident and sort of know how to do that, okay? Other thing I would strongly recommend that you do, because we have time before this next set is due, right? If you have existing data in your lab, okay, that are variables that aren't trauma related that have meaning to you, unless you're a trauma, like, so you're probably fine, right? Like, so, but if you don't care about trauma and would like to look at other things, just try and go through and grab some data in your lab that you're like, hey, I wonder if sort of this effect could be sort of moderated by this thing. And go through and practice and just run this, right? One, it's a nice exercise to be able to go through and say, okay, can I run these types of models in something that data that I care about and some variables that are interesting to me? Second thing is you might get a paper, okay? Like, these are still sort of really excellent analyses to go through and sort of generate papers from. Posters, papers, things along those lines. If it's an interesting idea, something that someone hasn't sort of taken a look at, something that's theoretically interesting, right? If it's possible that some effect that you found in your area might not be the same for always and forever for all people in all situations. This is the model to go through and test that on, right? So going through and doing this just kind of on your own, one, you get a poster paper out of it maybe, and sort of at the very least, you start starting to understand this a little bit more. This is going to be a really great exercise, okay? It just takes some practice to get this down before you start to feel confident. It's going to take several of these before you start to feel confident with this. So go through, work together, and just let me know what goes up with if you're running into questions. Okay. All right, cool. So last wrinkle with these models, okay? What SPSS does, anytime you run a regression analysis to get you a standardized code, standardized solution, all those beta weights, what SPSS is doing, sort of outside of your knowledge, in the blink of an eye, right, is what it's doing is it's going to go through and it's going to create z-scores for all the variables in your model. So it's going to z-score your y's, it's going to z-score all your x's. And then what it's going to do in the guts of its memory is it's going to regress the z-score your outcome onto the z-score of all of your predictors. And then it's going to look at the coefficients that it gets out of the model for that. And those are going to be returned as your standardized coefficients, okay? This is really easy to do. Like, and I would encourage you to do this, okay? And so like some of the regression models that if you haven't turned in your problem set yet, or if you have already, just go through some of those models that you ran. Go through, run those and look at sort of your raw models and look at your standardized coefficients. and then take the z-scores of your outcome and your predictors and just regress your z-score, your outcome out of the z-score, your predictors, and then look at the unstandard coefficients in that model. They should be identical to the standardized coefficients in sort of your raw model that you ran before, okay? It's easy to go through and do this. And this is why, remember that when we're interpreting our standardized coefficients, we're interpreting this literally as a standard deviation unit change in my predictor resulting in corresponding standard deviation unit change in Y. That's because this is what's happening, okay? Now, the problem is though, is when we go through and do this, right? This is the model that SPSS gives us, is it takes the z-score of Y, gives us the z-score of pain, the z-score of opiate use, the z-score of PTSD, and then it gives us the z-score of my opiate by pain interaction and the z-score of my pain by PTSD interaction. Because remember, we calculated these as physical variables in your data set. And what SPSS is doing is, because this is the only way it knows how to do things, Stata does the same thing, I imagine most R programs do the same thing, is they just take the z-score of that, okay? Problem is mathematically, right? Remember that when we go through and we tease apart and we restructure our equation, what we're doing is we're factoring this out. The z-score of my pain by opiate interaction that SPSS is creating is not the same thing as the z-score of opiate use times the z-score of pain, okay? And the z-score of pain by PTSD is not the same thing as the z-score of pain times the z-score of opiate use. I can't get, this is what I need. I need to be able to break these apart in order to get my conditional effect. I can't do that with what SPSS is doing. Okay. People kind of see mathematically what the issue is. So the z-score, think about like, so you went through and created interactions of opiate use and pain and PTSD in your data set, right? And it's just sort of this variable times this variable, right? And those are sort of now listed in number form in your as variables. But because of that, that's the way they're calculated. I can go through and decompose those into their original pieces through math, right? But if I go through and take a standardized score of like the raw values that I've gotten there, I can't pull those into z-scores of X and z-scores of Y, or excuse me, z-scores of pain and z-scores of opiate use. These are not the same numbers, okay? And so as a consequence, what happens is that, and if you go through and you see, if you wondered why through all of these, I have these little boxes canceling this stuff out. That's because these standardized coefficients that SPSS is giving you for your interaction terms, these are not technically appropriate. They're not accurate. They're not right. This is regressing the z-score of the interaction onto your outcome, as opposed to the z-score of X times, or z-score of one variable times the z-score of the other one. Okay. And so what we need to do to actually get your appropriate terms, right, is what we need to do is go through and do this manually, okay? So if you're running a moderation model and you're wanting to report proper beta weights, what you need to do is go through and take z-scores of your outcome and z-scores of your predictors, and then create new interaction terms that are the product of your z-score of your X1 and z-score of X2. And then rerun a standardized model where you're regressing the z-score, your outcome, onto the z-scores and your z-score interactions in order to appropriately get this. Because with this model here, now I can go through and restructure that model to get these components out appropriately. I can't do that based on what SPSS is giving me, okay? And so the standardized coefficients for your interaction terms that SPSS will give you will be close-ish most times, but they're not technically correct, right? So what we need to do is just do a little bit of an extra step and create these on our own, where we're just creating a standardized solution, creating a couple other interactions, and then taking things from there, okay? People see what's going on with this? Yeah.
So just to clarify, if we can't standardize our existing interaction term. We have to create a new
Yes.
interaction term with the Z-scores of the things that are interacting?
Yeah.
Okay.
Yeah, that's perfect. And then when you go through and run that standardized solution, April, what are you looking at? What coefficients are you looking at as your real standardized coefficients for your interaction terms?
Just the regular.
Yeah, just the regular, right? Because you're already plugging in the standardized coefficients, right? So what you're looking at is under B, you're just pulling those two. And so once again, a couple of extra steps to just get appropriate standardized terms for your interactions. Everything else will be the same. If you go through and you look at your in this standardized solution, if you look at your coefficient here, here, those would be all identical to what SPSS gave you in the original ones. It's just these two coefficients that you're only getting out. So again, it's work. But again, this is science. It's not just like, oh, kind of, right? So I really kind of feel like you should be going through. And you know what? The other thing too, it'll make you look like a boss in your paper because you go through and be like, hey, what we did here, so we went through and calculated these appropriately. And then you can cite Aiken and West, and then people think know what you're up to and not question anything else. They'll just accept your submission as is, no revisions, because they'll just be wildly impressed with your quantitative acumen. That's what's always happened. Questions about this and why we're doing this? Okay. All right. So what we've done up to this point is you worked with a simple slopes analysis. Okay. And simple slopes analysis in psychological research is pretty standard deviation above and below. Okay. And so we've got a continuous moderator. And again, we're not dichotomizing this. This isn't a median split, right? All I'm doing is I'm just recentering or rescaling where 0 is. So I'm not splitting anything into groups, right? I'm just changing what the 0 point is on my scale to be able to go through. And so what's beautiful about this is we continue to retain all values, the whole continuous scale, all information, everything's great, right? The problem is if I do this, or so someone tell me what might we not like about the simple slopes approach? Yeah, Connor.
It's kind of arbitrary.
Yeah, it's real arbitrary, right? What I'm doing is I'm looking at the conditional effect of X on Y at 2 random points along my moderator, okay? This tells me in general what my conditional effect looks like at kind of high levels and what it looks like at kind of low levels. But there's a whole lot, there's an infinite number of simple slopes that could be calculated across the full range of that moderator, right? And I might be in a situation where I might start to get interested in where the relation between X and Y stops being significant, right? So like at what point is my conditional effect no longer there? At what point on my moderator do I stop seeing a relation between X and Y? Or at what point on my moderator do things flip from a positive association to a negative association, right? Or across what range of my moderator can I expect evidence of an effect of X on Y, right? I can't get that with simple slopes, right? And what happens is, so people will talk about this as a pick a point, right? Because I could pick a standard deviation above or standard below. I could pick two standard deviations above and below. I could look at sort of a half standard deviation above and 3 standard deviations below. It's completely arbitrary and random, okay? And so again, if I have a truly continuous moderator, that conditional effect take off an infinite number of values, an infinite number of simple slopes, right? And if I, again, sort of the way I try and think about this is like, what are the boundary conditions? Like under what circumstances is X related to Y? Does it ever cross into 0? Does it flip, right? If I have a complete, an exact crossed effect, right? Where I see the conditional effect of X on Y at low levels of my moderator is negative. The conditional effect of my moderator at high levels is positive, right? there's a lot of interesting stuff going on there because at some point, right, where someone tell me what's the simple slope of x on in this graph, what's the simple slope of x on y at average levels of my moderator? 100. Yeah, 0, right? And so if I just look at the effect of x on y without including those interaction terms, what's it going to tell me? This variable is not related to my outcome. When in fact it very much is, it just depends wildly on to the levels of this other variable, right? And so this is why it starts to become so important to be thinking about model building and sort of model specification, because if I miss this, I can say like, well, it looks like x isn't related to y. No, it looks like x is related to y in important ways. I just missed it because I didn't allow that to come through, right? But in this case, there's interesting stuff because for a certain range of my moderator, x doesn't hold an association with my outcome, right? At some point, that relation is gonna start to be negative. At some point, that's gonna be starting to become positive. It'd be really cool to start to know kind of where that happens. I think there's some pretty substantial theoretical implications for knowing kind of some of these things, right? So this is where we go through and you see procedures like Johnson-Neiman. Has anybody heard of this before? Okay, this is super slick. I'm not sure why we're not doing this all the time. This is what I incorporate into all my interaction, any moderation analysis I do to this point. It's easier to do in state. I think you probably get SPSS to do it, but it just gives you so much more information. Okay, so with the Johnson-Neiman procedure, instead of plotting a simple slope for 2 or 3 different values, what we're doing is we're plotting out the conditional effect of x on y. So that unstandardized coefficient, the resulting confidence bounds are plotted across the floor range of the moderator. And so again, if I'm doing this in Stata, right, what I've got here, this is an iterative process, right? And this is why it's hard to do by hand. What I've told Stata here is to tell me to give me the conditional effect of PCL or of PTSD on some outcome at levels of my continuous moderator, starting from this level and then increasing by 0.05, right? And just run this, right? From this range to this range. And so what I'm getting is a simple slope here, and as my moderator increases by 1/100ths of a point, it's giving me a new simple slope for all of these. Okay. And what I get, so here I've got conditional effect of x on y for all values of my moderators ranging from 0 to 9 at 0.05 unit intervals. Okay. And so here, and so this is based on sort of former students' thesis, right? What Layla was interested in is looking at the effect of PTSD on interpersonal functioning at high and low levels of empathy. Okay. So someone tell me, Emma.
Bring it back.
Bring it back.
All right.
Tell me what's going on with this. What are you seeing?
So it looks like there is a stronger relation between TSD level and social functioning at low empathy and a slightly less, not significant, but I don't know what the word is better. It's not as steep of a slope, meaning there's less of a relationship there.
Exactly, right? And there's no p-values to this, so who knows what's going on. Exactly right. So good. I'm so glad I embarrassed you last week.
Really, I'm learning so much.
Right. You're exactly right.
Moment.
Right. So exactly what we've got here is we're saying the association, unique effect of PTSD on interpersonal functioning looks to be stronger for people with low levels of empathy as opposed to people with high levels of empathy. For people with high levels of empathy, it looks like we may not have much of an association between post-traumatic stress disorder and interpersonal functioning, but people with low levels of empathy, we're seeing a negative, what appears to be a negative association there, right? Cool, right? But this is just two this is just two possible versions of this modeled at low and high levels of empathy based on my sample, right? This is all going to be very unique to whatever standard deviation above or below is for my sample. That's what happens. And so this is good information. This is what we generally see, but it's still pretty limited. Yeah, Lucy.
I guess I was trying to like figure out, like with the Johnson-Naaman, like I thought we wanted to move away from doing like one standard deviation.
This isn't Johnson-Naaman. This is just simple slumps.
Oh, okay, I was
Yeah,
like,
this is just the regular.
okay, sorry.
Yeah.
I don't know why.
No, that's fine. And so what we see here is for empathy at a value of 3. Here's my of coefficient for a value of 8, standard deviation above. Here's my coefficient, and I see that at very low levels of empathy, I have very strong evidence for a negative association. At high levels of empathy, I don't have much of an association there at all. Right? Here's my Johnson-Naaman plot. Okay, this looks very different. What I've got here, so I've drawn a guideline at 0, right? This is a coefficient of 0. This says like literally no effect at all. Okay. What I've got here on this dark line is a continuous plot of the coefficient, right? This is the simple slope or the conditional effect of PTSD on interpersonal functioning across all possible levels of empathy. Okay. Here's the coefficient, and then the dotted lines are my confidence bound. Okay. What I can see here is that because it's a linear model, and I think Connor, you sort of talked about this, because it's a linear model, the relation between the coefficient has to sort of increase linearly here, right? So down here at empathy level of 0, right, we have a pretty noticeable negative relation between PTSD and functioning. As my empathy levels increases, that relation gets weaker and weaker and weaker until eventually what happens, and so again, here is a value of 3, right? This is a standard deviation below, and here's a standard deviation above, okay? And I can see at standard deviation below, this is my coefficient, it's going to be negative 1.63, right? And here's the lower bound, here's the upper bound, or the lower bound and upper bound. I know that that's associated with evidence for an effect because it doesn't cross 0, right? Here at a value of 8, this is a standard deviation above. Here's the coefficient, it's still negative, but the upper bound of my confidence bound is here, lower bound is here. That very clearly crosses 0, so I don't have evidence of effect here, okay? Well, what if I'm interested at what point does PTSD, at what level of empathy, at least based on these data, does PTSD stop having an association with interpersonal functioning? Well, based on my Johnson-Naaman plot, it looks like somewhere between a score of 6.5 and 7, right? Is where this confidence bound crosses over that 0 line. And so what I can say based on this, that I can't draw from this, is I can say based on my Johnson-Naaman that it looks like PTSD holds a negative association, a decreasing negative association with interpersonal functioning from minimum levels of empathy to a value on this scale of about 6.75 or something like that, right? And yeah, that's sort of what it is. And at this point, we get a p-value of 0.047. Here's if I tip one unit over, now all of a sudden, so I cross the line and some technically. So we're talking about, you can't, like I wouldn't put a ton of faith on this point exactly, but it at least is giving you kind of a ballpark in terms of boundary stuff, right? I could also sort of take a look at sort of different levels here, right? What's going on here? What's going on here? So this is, I can't remember what's interesting about 6.15. There was something I liked or wanted to go through and test on that. Can't remember. But anyway, so let's say if this scale is actually ordinal, right? So you can't actually have a value of 6.75. It's either 6, 7, things like that. I can go through and just look at what it is at 6. That's the lowest score where I still have an effect on this, right? So you can go through and take a look. All sorts of things I can do to play around with this, okay? But what we're getting is a whole lot more information based on what's happening with my moderator than I would with our traditional pick-up point of approach here. People see kind of what's going. Lucy, does this help see what's going on with Johnson, even how why it's providing so much more? Now the problem is this is not intuitive to most people, and it's hard to kind of wrap your head around. What I have typically done in papers is I provide them both. Right? Like, hey, here's if you just want to look at this, this is what it looks like. But if you're sort of really cool, want to nerd out and see exactly what's going on, here's some cool stuff with this. Okay. Then, so the old fogies are happy with this, and sort of the new folks are jazzed because you got sort of cool stuff. You calculate your interaction terms correctly. And just like they're gonna accept this paper and just like blindly accept sort of the next paper from you just because, right? You know so much and I'm so good at explaining things. Yeah. Questions about Johnson-Neiman stuff? Yeah, Emma.
So when you ran the Johnson-Neiman, you ran it from 0 to 9.
Yeah.
You're finding that within this specific moderation model, that the moderator is not impacting the association as strongly? Is that like, how would you word that you're seeing at 6, whatever?
Yeah. What I would say is sort of based on these data, I have evidence for a unique effect of PTSD on interpersonal functioning for values of the moderator ranging from 0 to 6, if that's the last real value that you can score on this, right? Okay. Once empathy increases beyond that, it looks like there we no longer have evidence, at least based on these data, that PTSD holds evidence for an association of PTSD on outcome. Now we start to get into some calculus stuff because what's happening is, yes, you do have an effect, but it's a decreasing effect as that moderator increases, but we still have evidence of this up to that. Yeah, Lucy.
The value 0 and 9 chosen because that was the range of the scale.
Yeah, that's just the sort of scale range from 0 to 9, and that was it, right? And again, I kind of like when I'm doing these is just plot the full range of the moderator because it kind of gives you the whole sort of gamut. Like I might not have people who have empathy at exactly 0 or all the empathy at 9, but at least gives you model projected values for this.
And for like point increments of 0.5, did you just use that because it kind of made sense with the scale?
Well, it just gives me a real fine grained analysis that I can go through and take a look. Yeah. And if the computer is going to do it anyway, awesome, right? Don't mess with the computer. I'll make you do it at 0.01, right? Something like that. But you just go through and sort of there are ways to go through and do this. R will do it sort of like in about a billion, probably different ways. You probably get SPSS to do it. I'm not exactly sure how you would do that, but there are maybe packages or stuff like that. You can go through, what you can do. Process will do this for you. Process will run this. I haven't ever done it, but again, Hayes is smart. He'll get you to go through and go through and do it. It's just creating this plot is what you have to do a little legwork on. All right. Oh, there we go. That's Stata stuff. That doesn't matter to any of you guys, but if you want to see me do this on Stata, you can go down through and take a link right there. What are you doing this week? Like, I'm gonna watch Josh do some statistics like every other goddamn week of my life. I'll get names. Okay.
Actually.
Makes it looks like I'm there. You're welcome. Okay. So if we're gonna go through and think about let's switch over and think about multicotomous indicators. Okay.
What's multicotomous?
Multicotomous means instead of dichotomous, where you've got two, you've got multicotomous means you have sort of more multiple levels to a variable.
But not continuous.
But not continuous.
Okay.
Yep. What we can do with this is we can go through and we can start to dummy code things to start to look at interactive interactive effects with categorical variables with a number of different levels, okay? Dummy codes, I'm sort of increased, I sort of, maybe like an increasingly antiquated term for things, but like sort of dummy code just means 0, 1. There are lots of different ways to go through code variables that do different things, but this is probably the easiest sort of way to go through and take a look at stuff, okay? Now, if we're gonna go through in dummy code, let's say I've got a categorical variable with 3 levels, okay? And April, let's say that this is condition A, condition B, and condition C, okay? They're just conditions that I randomize people to based on my experimental paradigm here, right? The number of dummy codes that you're going to create to represent this variable is going to be 1 less than the number of specific groups. Okay. So we think about opiate use, right? How many levels of opiate use did we have in our data set? 2. How many variables we need to represent that? Just 1, right? If I've got a variable with 4 conditions, how many dummy codes do I need to capture all of those? 3, right? If you go through and you create a dummy code with 4 levels, if you create 4 different dummy codes and try and stuff all those in a regression model, it's going to blow up on you because if I know in thinking about this, if I know your status, April, for condition sort of 1 or not, condition 2 or not, condition 3 or not. Is there any question about where you're at on that last dummy code? It's already been determined, right? And so we will always have 1 less dummy code than the number of categories that you need to find. Okay. So again, from Aiken and West is just a really slick example. Okay. They set up this example where we're interested in the unique association of degree and GPA with starting salary. Okay. So we want to know the unique association of degree and GPA with starting salary, and we want to know to what degree whether or not degree moderates the relation between GPA and starting salary, right? So again, does GPA correspond to your starting salary at all? Different if you're an English major versus an engineer versus an accountant, who knows, right? And so within this data set, we've got a degree variable here. 1 is a liberal arts, you got a liberal arts degree, okay? 2, engineering, 3, business, okay? And so you've just got a degree code here, it's just coded 1, 2, and 3, okay? And then GPA is continuous, salary is continuous. So we've only got 1 multicotomous variable here, it's degree program, right? Is this, can we treat this as continuous? No, that doesn't make sense. It's a nominal variable, right? So how do we represent this within a regression model? Well, what we can do, one way to do it, there are a lot of ways to do it. One way we could do it, we should go through and dummy code, okay? So what I'm going to do is I'm going to decide that liberal arts is my reference group, okay? So what I'm going to do is I'm going to create, so I've got 3 levels. How many dummy codes do I need? 2, right? So I've got a dummy code for engineering. 1, if this person is an engineering major, 0 if they're not. Okay. Then I've got another dummy code here for business. 1 if they're in business, 0 if they're not. Okay. How do I know if someone's a liberal arts major? Liberal arts isn't represented in there. How do I know if someone's how do I identify the liberal arts majors in this data set?
Where?
The one that's left over, right? If I've got a 0 on engineering, a 0 on business, who am I talking about? Talking about my liberal arts folks. Yeah.
Okay, this might be like a silly question, but won't liberal arts like have some sort of code in SPSS? Like otherwise it would just be like a missing value, right?
Nope. Because we've got and not a stupid question at all, right? Because in engineering, what's the value for someone in liberal arts and engineering? What value do they get in the engineering code?
0.
0. What value do my liberal arts people have in my business code? 0, right? And so if someone is a 0 in engineering and a 0 in business, who are we talking about?
Oh, then they're
The liberal arts people.
got it.
Okay, but here's what happens. If you go through and you give into the urge to go through and create a dummy code for liberal arts too, and throw all 3 of those variables in there, it's going to ruin your model, right? Because what you have is engineering and business, the bivariate association is 0. Engineering and liberal arts, the bivariate association is 0. Engineering and liberal arts, the bivariate association is 0. But if I throw all 3 of those in the model, I've created this singularity and the world explodes and we all collapse in a black hole, right? Because I've got sort of a multiclinearity, sort of a perfect, literally a singularity is what you would call it, is when sort of like a combination of 2 others perfectly predict a value on another one. Okay, so just watch that. You want to be careful with this. Okay, so if we go through and we run a regression model where we just have dummy codes, right? What we're going to do is we can do this to go through and look at a comparison in salary across different degrees here. Okay, so let's go through and we say we want a regression model where we have our expected salary is going to be equal to our intercept, and then we've got a coefficient for my engineering dummy and a coefficient for my business dummy. Okay, it's funny. It's funny. My engineering dummy is my business. I get you. I see what's happening. Right. Here's the model that I'm getting. Okay, I've got an intercept of $21,000, 6,999 for engineering and 3,000 for business. Okay, and if I go through and I apply a literal interpretation of this, what is 21,000 here? What does that represent?
Intercept.
It is the intercept. Yep.
Starting salary
Yep.
for someone who is a liberal arts major?
Beautiful. Yes, absolutely. Right. Because if someone is a liberal arts major, this is again the expected value of my outcome when everything else, when engineering and business is held constant at 0. Well, if engineering is 0, business is 0, that goes away. Who am I talking about? I'm talking about my liberal arts folks. Okay. Yeah. And here, what does this coefficient for engineering represent?
That can't be right.
It's how much on top of what they would make that.
Exactly.
Okay.
Exactly. Right. If engineering is
Oh, and then you pay
I'm
that.
not saying that these salaries are correct, but yes,
Absolutely not.
I mean, you're absolutely right. This is the additional sort of the expected additional starting salary that we would expect for engineers and then also for business majors, right? Because again, if someone's an engineer, then by definition, they're not a business major. That's 0, that falls away. And then we're just adding that to the base salary. So the liberal arts is like the base salary. Here's what we would expect on top for business, right?
Double major.
Right, well, it's, we don't have that sort of incorporated in the model, right? But if we go through and we plot this out, this is what's going on, right? We've got an estimate for liberal arts, right? And then we've got our estimate for our for our business majors and for our engineers, right? And these individual coefficients are the difference in the salary across these. People see how this is all playing out. What did we essentially just run here? We did run a regression, right? You're absolutely right. That's not incorrect. But functionally, what did we just run? If I had a grouping variable with 3 levels and wanted to look at the relation of those with a continuous outcome, how would I run this? Yeah, I just ran a one-way ANOVA in a regression environment, okay? If I go through and I take a look at my R² value, that's going to be identical to my eta squared. If I were to run this as an ANOVA, the F value from my regression table is going to be identical to the F if I would have just ran this as an ANOVA model, right? And what we're getting here that's actually really interesting is if I go through and I run this with an ANOVA, I'm going to get an omnibus test that says, yeah, we have differences in these. Then I'm going to have to go through and run a bunch of follow-up tests to see where things are different. If I just run it in my regression model, I don't have to do that because I already know exactly where everybody's at, right? Now, do I know here whether or not sort of these two are different necessarily from what? No, I don't. But it's at least telling me sort of I argue getting more information out of my regression approach than I would with just sort of my main omnibus effect. So again, that regression model is testing the hypothesis that salary doesn't differ across degrees. But let's say I go through and I want to go through, but hey, I got this GPA thing that I think is important, right? And so what I can do with this in this regression environment that I can't in an ANOVA is I can start to include another variable that's continuous, right? So what I'm gonna do now is I wanna go through and I wanna look at the unique effect of GPA once I account for different majors, okay? So what I do is I go through and create a new model, and so I've got my dummy for engineering, I've got my dummy for business, then I've got center GPA here. And so again, someone tell me what my intercept means here? April, go for it.
With the intercept,
Yeah, what does this represent?
the base salary of, is it still liberal arts?
Yeah.
Okay,
At,
oh, at, the mean GPA?
Yeah.
Or,
exactly. Mean GPA for the whole group, right? So what I've done is I've added an adjustment here, right? So this is the expected value for my liberal arts majors, holding GPA constant at the mean. Okay. Here is my expected addition for engineering on top of sort of my base at average levels. Here's my addition on top of for business, on top of liberal arts. And this is the unique effect of GPA with starting salary accounting for different majors, right? So I would say here, it looks like per unit increase in GPA, I'm expecting a $943 increase in bump in initial salary after accounting for different major types. And so again, what we've got here, if we go through and plot this out, here we've got GPA and we just go to standard deviation below and above. We've got the mean salary for liberal arts at average GPA or at 0. This is the difference, and then B3 here is the expected change in salary per unit GPA for liberal arts. But then if we go through and plot this out for engineering and business, right? What are we noticing about all these the relation between GPA and starting salary across these different majors? Yeah.
It's the same.
Yeah. Does that make sense? Why does it make sense?
Because like I think of how to word it. Your starting point will be different, but in theory, like your GPA would just kind of be independent of that and would influence
With this model, could I get anything other than parallel lines? No, I can't. Why not, Helena?
Same equation, you just be like putting a 0 or 1 in.
Yeah.
The value.
I'm just adjusting things. There's no mechanism in this model for GPA to impact or for major to impact the relation between starting salary and outcome. Okay. I'm saying sort of this is sort of the relation for starting salary with or GPA with starting salary technically for liberal arts majors because that's where this is 0 and this is 0. But this is the same estimated association between salary or GPA and starting salary for everybody because there's no mechanism for this to change across other groups. Okay. And sort of I think about this, and this is fine if this is how the world actually works, right? Is this likely how the world actually works? Does anybody here have friends, sort of people they know who are engineering majors? Or let's start with just engineering majors. Anybody know engineers? Okay. Anybody real concerned about GPAs? No, C's get you through these hard ass classes, right? Right. What about if you're a liberal arts major? Does C's get you through your liberal arts major? Probably, but like it's indicating something different than, and so probably what happens is there's probably some differences across here, right? So in order to do this, what we can start doing is adding in interaction terms, okay? And so what we're doing here is we're recreating this model where we've got our intercept, our dummy for engineering, our dummy for business, my center GPA variable, but now I have an interaction of engineering by GPA and business by GPA. Okay, this is what's going to allow us to see and test whether or not we have evidence for differences in the association of GPA with starting salary across these different majors. Okay. And so if we go through and we take a look at our simple slopes here, the simple slope for my liberal arts majors is just 2.98, 2982 times sort of this, right? How did I get to this? How did I get the simple slopes for the relation between GPA and salary for liberal arts majors? I'm talking about liberal arts majors. If this is engineering, they're not engineering, that's gone. That's gone. There's engineering, that's a zero, and that's gone. There's business, that's a zero, and that. Everything else falls out, right? And so what we've got is just within this base model, this is the, where is it at? This right here, 790, that is the simple slope of the relation of GPA and starting salary for liberal arts majors. Now, if I go through and this starts to become really slick because I can just start throwing in zeros and ones for stuff. If I want to look at the simple slopes for engineering, sweet, right? Okay, I'm just going to throw in ones for engineering and zeros for everything else, right? So I've got my base. This is one because I'm talking about engineers. Am I talking about business majors? Nope, that's gone. Here's my coefficient for salary. Engineers, yep, one there, so multiply that out. Talking about business, nope, that goes away because I throw a zero in there. What I get is a model that says, here's my intercept, coefficient for engineering, here's my simple slope or my coefficient for GPA, right? Minus sort of this coefficient here for the interaction of engineering and GPA. Well, if engineering is one, then that's just one times GPA times this. I go through and add that up. And here's my simple slope for GPA for engineers, right? And as we might expect, we see that this is a much, much weaker coefficient than it is here. The GPA doesn't matter so much for engineers. Okay. Same thing, if I were to do the same thing, just substitute one for business and zero for everything else. So it drops this out. And now I've got my simple slopes here for my business majors, okay? So again, if I'm looking at my main model here, this, my intercept, this is just the mean salary for liberal arts at GPA equals zero, which is mean GPA, right? Here we get difference in mean salary for engineering versus liberal arts at average GPA, difference in mean for business versus liberal arts. Here's the expected change in salary per unit in GPA for liberal arts, right? And then here, coefficients B3 and B4. This is giving me the simple slope for engineering. B3 and B5 simple slope for business. Okay. People see how the math works on this. What's really cool is that if you think about like we're starting to go through and throw in categorical variables. What's awesome is that the math on this actually just works out real nicely on its own. Do I need to go through and sort of start to restructure my equation and do a bunch of stuff here? No, I'm just swapping out ones and zeros for whoever I want to be and so what I want to look at, and it kind of lands the way I want it to. Okay. Now, if I would want to go through and test this simple slope, how would I do that in SPSS? What would I need to do? Because I can get the coefficients by hand. I can't test whether or not they are, I can't get p-values for these. How do I do that?
Run a t-test.
What's that?
Could you run a t-test?
Well, not really a t-test because I'm sort of interested in I'm testing these individual coefficients. Based on what we did in the last example, how would I get p-values for these?
Just run regressions.
Yeah, run regressions, and what would I do with those regressions?
to like run it for 0 and for 1, or I don't know.
Which one of these, if I run this model, what group am I gonna get a p-value for the simple slope? Yeah, my liberal arts, okay? So if I wanted to get a p-value for my business majors, what should I do? Yeah, just make business majors my reference group,
Okay.
right? And then I'm gonna run another one where I just make engineers my reference group, right? So I'm gonna have a different combination of interactions, right? So that here, Lucy, I will need to go through and create a dummy code for liberal arts because in some of these, like liberal arts is not gonna be the reference group. And so then what I'm gonna do if I wanna go through and test this simple slope for engineering, right? All I do is recreate a model where I have a dummy for liberal arts and a dummy for business, corresponding interactions. And now all of a sudden this coefficient right here is the simple slopes for engineering. And then I run a different model where I have dummies for engineering and dummies for liberal arts. And now this coefficient here, then my model is the simple slope for my engineering folks, right? So again, it's just playing around and saying like, okay, what's the zero? Zero is such an important concept within these models. Always know what zero means because that's what it's telling you specifically what's being tested, particularly in these multiplicative models. In the additive models, it doesn't matter because they're all the same, right? Outside of the intercept. But for these moderation models, critical to know what zero means with stuff. Okay. So yeah, simple slopes here. We're just going through and now for us in my base model that we already talked about, coefficient for B3 in the original model, that's just my simple slopes for my liberal arts because they're my reference group. Simple slopes for engineering, I just recreate to reorder my dummy variables. So I got a dummy for liberal arts, dummy for business. It's going to be a different dummy for business because now 1 is going to be business, 0 is going to be engineering and liberal arts. You got to make sure that you create a proper dummy code for that, right? Because your original business dummy had a 1 for business. Well, no. Yep, no, that's not right. It's still the same one, right? Because it's just for business and not for others. And then the same thing swapping this out, right? To give you each one of those. And here, if we go through and plot this out, we'll go through and see for engineers, GPA doesn't matter. Here, it looks like for business, it does quite a bit. For liberal arts, it doesn't because our starting salaries are garbage anyway. Matter if it's a good garbage or bad garbage, right? So what's we got going on here? Okay. So again, Aiken and Wes have some alternative coding systems that you can go through. You can contrast because there's a lot of there. You could do like half a class just on how you go through and code these, right? But for our purposes, the dummies, our business dummies and our engineering dummies are going to work just fine. Okay. All right. We made substantial progress today, okay? How are we feeling about moderation stuff? Still a little shaky, sort of ishy, okay? If you're feeling kind of sort of like this, that's awesome. That means you got it under control, okay? Sit down with sort of actual sets, start sort of kind of trying to work through some things. I know you've got a problem set coming up that's due on Friday. But while this is still kind of fresh in your head, I would probably maybe just go back through notes, take a look, sort of write out. Don't be afraid to write out these models. That's going to be amazing. We just get practice in terms of writing these out. And then sort of once you get done with this set, just start poking around with the next one sooner rather than later, as opposed to letting this kind of fade out and then have to go through and catch it up. But still, I would say go through. Watch that second example of that screening, watch that second example of the moderation. Make sure that you're following things. And if you do that, you should be in a pretty good spot with stuff. Sound good? Okay. So, excuse me. Problem set 4, obviously will not be due next Friday. We'll finish up the last couple of slides next week. And then this moderation set will be due that Friday before spring break. What's that? 4. 4. Problem set. Is it 3?
It's 3.
3.
Yeah,
Okay.
moderation. Hold on. Did I forget to?
I have a follow-up question.
Yeah.
Next Friday is the Friday before spring
Next
Yeah.
Friday is the Friday before?
Yeah, because the spring
Okay.
break is on the week of the 17th.
All right, well, cool. Well, then you got like spring break to spend on moderation examples if you want to. Right?
Okay.
So it'll be due the
Week after?
the 28th. Oh,
Sure. Yeah, let me see here. All right. Oh, yikes. Yeah, we are getting close, huh? All right, so, really up to you. How you want to do this? I would strongly suggest doing it sooner rather than later, right? So your spring break is yours to sort of use on as your own, right? Like, so I don't know what people's plans are and things like that. Probably getting this in sort of earlier rather than later is gonna be sort of helpful, right? If though you're kind of slammed and you want to spend, you're not staying pretty low key and local or something like that, and you want to pick it over spring break, that's fine. What if? That's just a lot of time. If we had like the Monday after spring break as kind of a due date, kind of a due date for this set. Is that acceptable for people? Like, I mean, like, it just gives you a sort of a sooner deadline than sort of dragging it out to the very end.
24th.
Yeah.
I think that makes
Is that fine for people? Like, I don't want to be
No,
a goddamn older and say like right after spring break, but
Same time, like 12 noon.
yeah, we'll say end of the day.
That still
Okay.
gives us 2.5 weeks.
That's like
Yeah.
plenty.
Yeah.
Awesome. You all are fantastic. Thank you so much. I think this is a good plan, right? We're going through because what we'll do next week is we'll finish up with, we'll get this done and finish up with, mediation next week. And so what you'll have then is a sort of you have a mediation set that's sort of due after that, just to give you some examples, some experience with those mediation analyses. But one, those are super easy, and there's only two problems on that set. Like it's not a hard thing to go through and do. So what I would encourage you to do maybe is go through, start on this one, and then pick up sort of the mediation stuff after next week. We go through and work through stuff and start working on those. We obviously will sort of give you some time to go through and do those, but if you go through and knock those out quickly, that will be a sort of a useful thing to do. So, yeah, Carter.
So when you're saying it'll be due shortly, is that like the moderation set will be due on Monday, the mediation set will be due on Friday? Or?
That seems unreasonable. But we can go through and talk about kind of just see where we're at and sort of how people are feeling and stuff. Okay. What I don't want to do is drag stuff out because when you go through and then you get the set back to me, then we got to score it and get it back to you. I will be much more efficient than I typically am with that, just so you'll have that to go through and take a look at. But what I also don't want to do is kick the mid-semester exam down the road to it's been forever and ever since you actually were doing the stuff. So. Yeah.
That was gonna be my next question, is if you had a date in mind for the midterm.
I'm not sure. Let's go through and see kind of where these fall, and then we'll kind of take it from there.
Okay.
Does that work? Okay, awesome. You all are champions. Thank you so much. Yeah, let me know if you're running this next.
Okay. Very good. So we're good.